This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, today we'll be talking about a very important topic in physics, which is graphs. So, why is it used in kinematics? That is one of the basic questions, as in what is a use of graph in kinematics when you can simply use the equations that we have learned before to find out some of the values. But graph is very important method of representation of data. It is very frequently used. So you should be able to find out a lot of important information just by looking at a graph, and that is the exact purpose of this video. So first of all, let's talk about the kinds of graphs that you have in your syllabus or that you will study at this level, at your IGCSE level. First of all, the first one is the displacement time graph. Displacement, it is also denoted as an ST graph. Okay. In a displacement time graph, something like this happens. Take a line here. Let me take a line here. You would know from your maths lessons that this is called your y-axis because it's vertical. The vertical thing is called the y-axis, and the horizontal line is called the x-axis. Now, in a displacement time graph, the displacement is being represented by the y-axis. So here you have the displacement in meters. This part of the graph will show the heights of every point, will show the displacement, and you will see how. However, the x-axis shows time in seconds. So this is your x-axis, and this shows time running along the x-axis. So this is how a displacement graph looks like. Obviously there is something in between, but we will come to that later, just to make you familiar with what a displacement time graph looks like. Now, the second one in line is the velocity time graph. Now, in a velocity time graph, which is also denoted as VT graph, where V stands for velocity and T for time. In a velocity time graph, and here you go, this is your y-axis again, and this is your x-axis. I don't need to write this again and again because I think you would know this. So on the y-axis we have the velocity, and which is expressed in meters per second. So we always write the units with a slash here. On the x-axis we have the time running, which is expressed in seconds. So the heights or the vertical things will give me the velocity, whereas the horizontal things will give me the time, and you will see how. So this is what a velocity time graph looks like. Now, the last one here is the acceleration time graph. Acceleration time graph. This one looks something like this. Again, procedure is the same. You know the y-axis, you know the x-axis. Let's just draw a line here. This is your y-axis and this is your x-axis. So this is your acceleration, small a. This is in your y-axis with a unit of meters per second square. It's expressed in meters per second square, so you always write it here. And the time expressed in seconds. So this is how an acceleration time graph looks like. Now, let me give you some type of graph. Let me tell you about the type of graphs that you will see. And you should recognize it. And this will work in all the three cases. And you should understand. The first one is a linear graph, or linear means straight line graph. And the second one is the non-linear curve, or a not so straight line Now, let me give you an example. I'm not drawing the. I'm not telling you which graph it is. It works for all three of them. Okay. So here it is. This is your y-axis, and this thing here is your x-axis. So this is your positive y-axis, and this is your negative y-axis. Always draw these arrows. This is your positive x-axis. So a linear graph looks something like this. Or something like this. This is a straight line. Or something, sorry, let's curve it a little. Or something like this. All these are examples of a linear graph, which means a straight line graph. However, let's talk about the non-linear one. This is what happens if I do not use a scale. That is why I'm using a scale. Anyway, so a non-linear curve can look something like this, or this, or just simply this, or this. Anything that is not straight, or this. All these are examples of a non-linear curve. Now, for a linear curve, there is a property that we will be talking about. I'm just introducing it here right now. It's called gradient. Most of you will know what a gradient is. If you do, that is great. Otherwise, I'll introduce it right now. Gradient for a linear line is constant in a linear curve. However, gradient in a non-linear curve is not constant. Just remember the word gradient, and I'll be introducing it in the next slide and what it means exactly. So gradient in a linear curve is constant, and gradient in a non-linear curve is not constant. So there are two types of graphs, and we will come across both of them. We'll see how to tackle them.